Okay, g'day folks, welcome back to KIERAN'S training. So today we're going to take a look at the calculations required for a C1 license. C1 license is a slewing mobile crane up to 100 tonne. Now, just like the previous ones we've done with the crane calculations, a lot of it is based around the crane's load charts. So being up to 100 tonne, we're going to use two types of load charts today. We're going to use the load chart for a Liebherr LTM 1095 and also for a Grove 70 tonne roughie. Okay, and just like the other ones, there's also going to be a question or two in there about outrigger pressures. Alright, so let's dive straight into it. So I will just minimise this so we can have a look at what's behind. Right, we'll take that up there, get me out of the way. Okay, so in our first scenario, we've got the Liebherr LTM 1095 5.1. We're set up using 13.6 tonne of counterweight and a 3-sheave hook block, and we've got 37.6 metres of boom length. Okay, so that's our setup. Let's look at what the question is. Okay, let's copy that and bring that over here. Okay, so our first question, we're picking up a load weighing 8,100 kilos. Okay, we've got 50 kilos of rigging equipment. We've got a 12 metre radius. Okay, now it's asking when we're booming down with the load, between which two radii would you expect the 90% capacity alarm to sound? Okay, now when we're looking at this question, a common mistake people can make is they can, firstly, they'll just find 90% of the load capacity, or 90% of the load weight. That's not what we're looking for. Okay, we want to know when we're going to reach 90% capacity of the crane. Okay, they are two very distinct differences. Okay, so first of all, we need to find out the total weight of the load. Okay, so if our load weighs 8,100 kilos, we've got 50 kilos of rigging, we've got 8,150 kilos right there. Now on top of that, we have our 3-sheave hook block, so we need to discover how much the hook block weighs. So we'll run over to our load chart. So we'll bring it over here and we'll just scroll down to find out what the weight of that 3-sheave hook block is. Okay, so we'll just come down, right, and well, I think I've just gone past it. Alright, here we go. You see this little picture of the hook block there. Now that emblem represents your hook blocks. Now if we have a look, the second column where it says number of sheaves, okay, so we're looking for a 3-sheave hook block. So we just come down here, you see a 3-sheave hook block, run across down to the end column, and it will give you the weight of that hook block. So our 3-sheave hook block weighs 450 kilos. Now if we add that 450 kilos to our 8,150 we've already got, we're going to end up with a total load of 8,600. Let me just bring that across here so we can have another look. Okay, so total load 8,100 kilos plus our 50 kilos of rigging plus our 450 kilos hook block, so we've got a total load of 8,600. Now to find out when we're going to hit that 90% mark, we need to make sure we're looking at the correct load chart to start with. Now we're set up with 13.6 tonne of counterweight, so we will scroll back up to a load chart. Now keep in mind it's only got a live boom, so if you see these pictures of a fly on it, you're not on the correct load chart. So we will keep scrolling up until we get to the right one. Okay, 13.6 tonne, but we've still got the fly. So we will continue going up. 13.6, and now we're working with a live boom. Now we are set up with 37.6 metres of boom length, so we're going to be looking at this column down here. 37.6 metre boom, 13.6 tonne counterweight. Now if we scroll down here, our total load being 8,600. So if you have a look there, at 18 metres, you can see you're still good for 9 tonne. But we want to know when we're going to hit 90% capacity, not 100. So what we can do is if we work out 90% of 9 tonne, let me show you how we're going to do that. So, you got 9 times 0.9, because we want 90% of it, 8.1. Alright, so we're not going to go that far. Right, because if we go to 18 metres, we've already exceeded past 90%. So, let's go back one. Let's go to 16 metre, where it says we're good for 10.7. Let's just cancel that. We go 10.7 times 0.9 to find out 90%, 9.63. Alright, so at 18 metres, we have gone past our 90%, and at 16 metres, we haven't quite reached it yet. So, at what point are we going to reach our 90%? Well, it's going to be in between those two. Let's copy that and bring that over here. So, our 90% is going to be somewhere in between that 16 metre and 18 metre radii. Okay. So, that's a rather simple one there. We'll go down to the next question. Our next question. Let's copy and paste. Now, using the above setup and load, what's the maximum outrigger pressure that is applied? So, just like on the previous ones, the let's bring this across so we can have a look. So we've got our total crane mass, which is 60 tonne minus 1.4 tonne equals 58.6 tonne. Now, how do we figure out that crane mass? What we'll do is we'll run over to our load chart. So if we come down, back down to the bottom. So if you look where your axle weights are, so if we look here, our axle weights, so that's in travel mode, it weighs 60 tonne. Now, if you look in the small writing down below, I'll make that a little bit bigger if I can, so it might be a bit easier to see. Maybe not. Now, in that fine print down below, it tells you that 60 tonne road weight is using 15 tonne of counterweight. Now, we don't have 15 tonne on, we've only got 13.6. Okay, so in order to work out how much the crane weighs with 13.6 tonne, then we just minus that difference between the 15 tonne and the 13.6 tonne. Now, if we were to be operating with, say, 23 tonne, what you do is you'd add an extra 8 tonne to make the difference from the 15 to the 23. But in this instance, because it's lower than the 15, then we're going to subtract the difference. Now, the difference between 13.6 and 15 tonne, 1.4. So the crane mass, 60 tonne, as it is there, minus the 1.4 tonne less counterweight we have on it, means our total crane mass in this configuration is 58.6 tonne. We've got a load of 8.6 tonne in total, so that's including our hook blocks, etc. So to work out our outrigger pressures, we've got our crane mass plus our load, and then we multiply that figure by 0.65. Now that figure's not going to change, it's always going to be times 0.65, okay, which gives us a total outrigger pressure, or maximum outrigger pressure, of 43.68 tonne. Now, moving down to the next one. Bring that over here. Now, in the above scenario, would 1 metre by 1 metre pads be sufficient if we were to set up on asphalt? Now, in order to do that, we need to know what asphalt is good for. So I will bring this over here so we can have a look. Now we've got our various ground types shown here, and as we can see, asphalt here is good for 20 tonnes per metre squared. Now, are those pads going to be big enough with this? We go back to our formulas. I will copy that and I will paste that down here. Now, the formula is your crane mass plus load mass times 0.65. Now, you can just use the answer you've got up there to avoid doing all that again. So if you have the answer you have up here and you divide that answer by your tonnes per metre squared for asphalt, 20, you're going to come up with an answer of 2.14 metres squared. Now, if we have a look, so 1 metre by 1 metre pads is 1 square metre. So pads we're going to need are 2.184 metres squared. So the pads 1 metre by 1 metre aren't going to be sufficient for the task. Okay. So if you just let those two follow on from each other, on question 2 here, you get an answer there. Now, going on to the next question, all you really need to do is divide your answer here by the tonnes per metre squared in the table below. And that will give you what size pads are going to be required in order to operate on that type of ground surface. Going on to the next question. Let's bring that across. Now, still set up in the Liebherr 95 tonner. Now we're set up using 23 tonne of counterweight. Got a main boom length of 54.4 metres. We have a 42 metre radius, a 7 metre fixed fly, and a 19 metre of folding fly set at a 40-degree offset. Now the first thing we want to do there is we want to find the correct load chart. So we run over to our load chart. Now we've got our 23 metres over here, but we only have a 19 metre of fly. So we will keep scrolling down. Now we can see we've got a 7 metre and a 10.5 metre. Okay, but we want 7 metre and 9 metre. 23 tonne of counterweight. Alright, so it looks like this is the load chart that we're going to be looking for. So once again, 7 metre of fixed fly, 19 metre folding fly, 23 tonne of counterweight. Make sure you've got all of those in there. It makes it very hard to come up with the right answer if you're not looking at the right load chart. Now, let's get to see what the question is. Alright, so let's copy there, paste over here. Question 4. What is the minimum radius that you can pick a load in this configuration? Now, we have 54 metres, so if you look across the top, you'll find the 54 metres. That's with a +7 and your 19. We've got a 40-degree offset. So this is the one we're looking at, this column right here. Now, running down this column, question is minimum radius you can pick a load up at. So basically, we need to run down this column until we get to the first figure. That first figure is the closest that we can pick the load up from. And if we have a look, run it across, that's a 28 metre radius. So the minimum radius in this configuration is going to be 28 metres. Nice and simple. Let's run on to the next one. Let's copy that, bring it over here. Now, in the above scenario, using a single fall hook block and 50 kilos of rigging, what is the maximum load that can be lifted at a 42 metre radius? Now, in order to answer this, we need to find out the weight of a single fall hook block. So we will Well, while we've got this load chart here, let's have a look and get the crane capacity first. Now, at a 42 metre radius, if we have a look here, and we're looking down at this same column, so run down this column until you get to 42. So the crane is going to be good for 1,300 kilos. So let's just put that in there. So that's the capacity of the crane. Let's work out the rest of it. So a single fall hook block, we need to run back down to our hook block weights. Once again, looking for this little emblem here for the hook block. Now, don't get these two mixed up. So this second column we previously looked at, that was for the number of sheaves in the hook block. Single fall hook block, that's your headache ball, single part, single line, a few different bits of terminology. In the load chart, it's going to tell you the number of lines. So a single line, that's the one down the bottom here, weighs 140 kilos. Now we've got our 1,300 kilos we had down here. We need to subtract the weight of the hook block and the weight of the rigging. Let's throw this over here. So we've got 1,300 kilos minus our 140 kilo hook block minus our 50 kilos of rigging gives us a total load capacity of 1,110 kilos. So at that radius, in that configuration, the maximum load that can be lifted, 1,110 kilograms. Moving on. Now, next question. The Liebherr, we're now doing a dual lift using another crane as well. The maximum load share on the Liebherr is going to be 3.5 tonne. Now, being a dual lift, we're going to have to allow an extra 20%. So, allowing an extra 20% for the dual lift, what is the maximum required capacity for that Liebherr? Alright, so it's quite simple. If you've done intermediate rigging, you should already be all over this one. If not, I would highly recommend it. So 3.5 tonne minus 1.2, sorry about that, multiplied by 1.2 is going to equal 4.2 tonne minimum capacity required. Now the reason for that extra loading is because you're not always, the load share is not going to remain the same. One crane may rope up a little bit quicker than the other, throwing the weight onto the other one. Okay, so doing a dual lift, you're always going to allow 20% loading. 3 cranes, 33%. 4 or more cranes, you allow an extra 50% loading. Okay. Rather simple that one though. Alright, I think we're going to go on to the Tadano next. So let's have a look. Bring this across. Alright, you're now operating a Tadano GR700EX on rubber, using a 40 tonne hook block to pick up a load directly in front of the crane with a 27.75 metre boom length. First question on the Tadano, what is the maximum load that can be lifted while the crane is stationary? Alright, so first we want to do, bring up the right load chart. So we've got our 70 tonne Grove. So we're set up on rubber using a 40 tonne hook block. Alright, let's find a couple of bits of details. Alright, so if we come down. Alright, so you notice here you've got on outriggers. That's not what we want. On rubber means we're operating off the tyres. Alright, so we'll skip past all the ones with on outriggers. Okay, keep coming down. Okay, on tyres. Alright, so this is what we want. Now, while we're coming down, alright, if we look at these notes down below, alright, it's going to give us a little bit of extra information too. So it says we've got the 40 tonne hook block. So if we have a look down the bottom here, so the mass of the hook, so 850 kilos if you're using the 70 tonne capacity, or 470 if you're using the 40 tonne capacity. Alright, so the hook we've got on is going to weigh 470 kilos. Alright, so back up to our chart. Okay, what we're looking at, directly in front of the crane with a 27.75 metre boom length and stationary. Alright, so you'll notice a couple of charts here on tyres. You've got stationary at the top here, and the lower one is when you're creeping, so mobile with the load. 27.75 metres of boom length, so we're going to be looking down this one. And what are we asking? Put done, pick up a load directly in front of the crane, 27. What is the maximum load that can be lifted while stationary? Alright, so 27.75 metres, stationary. Just come down here. Your maximum load is going to be your first one on the chart. Alright, so in this instance, 6,100. Now, not forgetting, we do have that hook block, so we need to be able to deduct that as well. Alright, let's bring this across. Oh, let's go. So, 6,100 kilos capacity of the crane, minus our 470 kilo hook block, leaves us 5,630 kilos. Alright, so in that configuration, that's the maximum load that we can be lifted. Alright, moving on to the next. So, part B. Now, what is the telescoping condition in this scenario? Alright, so this one's asking what boom sections you have out and to what percentage. Alright, so all we do, if we look down at this 27.75 metres on the load chart here, alright, and we just look at the telescoping condition underneath it, alright. So here we're looking at this scenario here, where the second boom is 100%, third, fourth and top boom are all at 33%. So, quite simple, you just need to know where to find the information on the charts. The other important thing, make sure you are looking at the correct chart when you're doing these. So copy that and paste it over here. Alright. Alright, so, as I said, over here on the chart, second boom, 100%. Third, 33%, fourth, 33%, and the top is at 33%. Alright. On to the next question. Now, can the crane travel with the above load and why? Alright, now to find out whether or not it could travel, all we do, so if we have a look, so there we're good for 6,100, alright. If we go down to the creep, alright, 27.75 metres of boom, alright, the maximum load we can lift is 5,500. So obviously with that load, we're not going to be able to do it while we're creeping with the load, alright. So let's copy and paste this over here. Alright, so no we can't, as the creep chart does not allow it. Alright. Now these are pretty important things to keep in mind as well. Okay, copy. Alright, now can the crane slew at 5 degrees with the above load? Alright, so once again, this is stationary over the front. Now, if we look down here, alright, at the 360 degree rotation, alright, there's no boom length there for 27.75. So, with only 5 degrees, can we still count that as over the front? Well, let's go down and have a look and see what over the front does say. Actually, I believe it's above it from memory. Here we go. Alright. So, if we have a look here, no, I think down below, here we go, the working area. So over the front, alright, is 2 degrees from the centre. So if you can only go 2 degrees from the centre to be counted as over the front, means we are unable to slew 5 degrees with that load. Bring that across again. Alright, once again, it's just a matter of knowing where to look. Alright, and you need to be able to find this information, because it's very easy to pick a load and to start slewing without thinking about it. Alright, make sure you do check these information. Alright, so in this example, if we were to pick up that load and you did want to slew with that load, alright, it's a good idea that you would suck that boom all the way in if you could, and then you could find out that you could actually slew with that load. Alright, but in that particular configuration, you won't be able to do it. Okay, next one. Copy and paste. So the Tadano is now set up on Outriggers with a 7.2 metre spread. We've got 35.87 metres of main boom and a 9.9 metre fly jib with a 25 degree offset. Once again, first thing we've got to do, make sure we find the correct load chart. Alright. So, where are we? Alright, on Outriggers, 360. Alright. So, 35.87. So, Outriggers to middle. Outriggers to middle. Outriggers to middle. Outriggers fully extended, 6.7. Outriggers fully extended, 7.2. Alright. So far, that meets what we need. 35.87 metres of boom and a 9.9 metre jib. Alright, so if you have a look on the top sections, alright, that's where you're going to find what you want. Alright, so this is the one we want. We want 35.87 metres of boom plus a 9.9 metre jib. Alright, 25 degree offset, which means we're going to be looking down this column here. Let me just... Alright, so this is the column that we're going to be looking at. So, question is, alright, bring that across. Now, what's the rated capacity at a 22.6 metre radius? Now, where are we? So, at a 22.6 metre radius, so at 25 degree offset, you can see your radius and you can see your capacity there. So 22.6 means we're good for 3,500 kilos. Alright, so this is just asking the capacity of the crane. It's not asking you to make any deductions. So it's only simply asking what is the capacity of the crane at that radius. So let's bring that over. So 3,500 kilos. Alright, now one last question. Alright, and it is quite a simple one. Let's bring it across. Now what's the boom angle at the above radius? Alright, back over to our chart where we've got our 3,500. If we just run right across to the other end, alright, right there you can see the boom angle is at 65 degrees in that configuration. Right there, that's where you want it. Now, that covers essentially the type of questions you can expect if you're going in to sit your Slewing mobile crane up to 100 tonne. Just like any other crane assessment, just like when you're operating the crane, it's very important you do know how to read and understand the load charts. Load charts are like the Bible for the crane operator. You can't really do without them. They are a pretty essential bit of tool and you must understand how to read them. Now, that should just about do us for today. That covers off all our calculations required. Now, just remember, if you do want to keep up to date with anything, any changes, anything that comes along, I'll be putting up some other videos again about some other equipment we may be using while doing dogging, rigging or cranes. So if you want to keep informed, remember to hit that like and subscribe button and you'll keep up to date with any changes as they happen. Alright, thanks for your time and thanks for tuning into KIERAN'S training.